What is this, a Levi Dockers commercial? Lovely peg with darts. Hey, hey! Howdy, welcome to This Old Corner Reflector. I'm Bob Fatland. Actually, my name is Rob, and for the next 20 minutes or so, we're going to be going with you step by step through the process of assembling and deploying a trihedral corner reflector, a device used for the geometric and radiometric calibration of synthetic aperture radar images. Now in this video, we're assuming that you're familiar with several important aspects of the deployment process. And they're important, so I'm going to read them. First of all, we assume that you are familiar with your radar platform flight track and that you know the resultant alignment characteristics of the trihedrals that you will be deploying, both pointing and elevation. We assume that you know the image swath location and uncertainty and have a clear plan for the placement of the corner reflectors within that image swath. This video also assumes that you will be deploying the corner reflectors on standardized mounting stands on a relatively flat, unobstructed open area with penetrable ground. Furthermore, we assume that your sites are relatively free of natural destructive forces such as hurricane force winds, mudslides, clumsy cows, and so forth. Okay, now there are 5 basic steps in the deployment of a corner reflector, and 6 if you count cleaning up afterwards. I will go over them quickly here, and then we'll go back over them one by one in more detail. The first step is to select your deployment site. We're sitting up here on top of the tallest building in all of Los Angeles to demonstrate what a lousy deployment site looks like. While it's true that a flying platform will have an unobstructed view of this site, there's no room up here to set up an 8-foot aluminum pyramid. And furthermore, since we are deep within the heart of the city, the corner reflector returns will be drowned out by strong double bounce returns off of concrete buildings. Also, there's nothing up here for you to pound a ground stake into. So when you choose your deployment site, choose a site that's out in the middle of a flat, open, unobstructed field. Bummer. Like this one. Why don't you go ahead and take a look around? Now, there's still a lot of obstructions at this particular location, but for purposes of this video, we're going to be using this field to show you how to set up your corner reflectors. Okay, now so to continue listing the 5 steps, the second step is the logistical task of getting your tools and your hardware out to the site. And the important thing to remember when you're doing this is to make sure you get everything you need before you leave, because often the sites are far away and it's a real pain to get out there and find out that you forgot stuff. That's step 2. Now included with this video, there should also be a memo listing the hardware you need, the tools you need, and going through this procedure step by step so that you can refer to that and have a checklist before you leave. So now going on, the third step is to assemble and align the corner reflectors at the sites. And generally this will require, for any particular site, about 2 people working together, and it will take them about 45 to 90 minutes, something like that. After you've done that, the 4th step is to align the corner reflectors and to measure their position and their attitude. And position, by that I mean you want to get their map location as accurately as possible, latitude, longitude, and their attitude. You want inclination and tilt and all the other things that will characterize how your corner reflector is aligned when the radar flies over and images it. Okay. Also, if possible, you want to be able to take pictures of the site. Now the 5th step is to clear the area after you've got everything set up and measured, and monitor your trihedral sites over the course of the experiment. And that includes, when the experiment is done, going back in and re-measuring the alignment. You don't need to measure the position, but re-measure the alignment to find out if they've been bumped or moved or somehow changed their position, their attitude. All right. Now finally, when all this is done, you want to reverse the procedure and pack everything back down into crates and ship it back to where it came from, hopefully no worse for the wear. And that's it. It's all pretty straightforward. We're going to try and tell you some of the details we've picked up over the course of doing this several times, and that's about it. So since we've already covered step 1, picking your site, We'll now continue with step 2, which is the logistical task of getting the equipment and the tools out to the site.
Hello, my name is John and I'm the second narrator. I'm going to take you through step 2, which is assembling all the things you're going to need before going out to the deployment site. Now behind me here, you see the 3 8-foot aluminum panels, which are the corner reflector itself. You're also going to need 2 wooden front mounting stands like this one here. Each of these mounting stands with a small hole through which a metal ground stake is driven to anchor it to the ground. You'll need a rear mounting stand, also with ground stake holes, to prop up the rear of the corner reflector.
Now we're going to take a look at the remainder of the hardware used to put the corner reflector together. The faces of the corner reflector are attached to each other using nuts and bolts like this one here. Now you're going to need about 40 per corner reflector, so it's a good idea to have an ample supply. Once you've assembled the corner reflector, you'll need to attach it to the wooden mounting stands we just saw using bolts like this one here and washers like this here, which protect the metal surface of the corner reflector. You're also going to need a roll of steel wire like this one here, crimps, which are used to close loops made with the steel wire, S-hooks, and turnbuckles. These things are used to make what we call a guy wire assembly, which consists of a piece of steel wire, each end made into a loop closed with a crimp. At one end we have a turnbuckle, which is attached to the corner reflector using an S-hook like this here. On the other hand, the guy wire assembly is attached to a metal ground stake using another S-hook. You'll need a pair of gloves to protect your hands. We use a Magellan GPS receiver to get an extremely precise fix in our position. In any case, you'll need a good topographical map of the area along with a compass, not shown here, a level, and an inclinometer. And these things will let you get a good fix on the position and alignment of the corner reflector. You'll need a cordless power drill like this Makita here, along with a set of appropriately sized drill bits, and hex drivers which will facilitate quick assembly of the corner reflector. A 35mm camera is important to record the site on film, and any other information you want to note, you will need a notebook and pen. You also need a hex driver, wrench, diagonal pliers, which are used to make the crimps, and a small sledgehammer. You also may find useful a cooler full of drinks and liquid nitrogen, a ceramic cobra, especially in sites where there's a high possibility of heavy rainfall, a tape measure, Swiss Army knife, crowbar, which is especially useful for getting out stuck ground stakes, clamps and vice grips, adjustable wrench, screwdriver, and files. Please refer to the memo which should come with this video listing all of the things you'll need, and use that as a checklist before you go out into the field. So now that you've seen all this, we're going to load it all up into the truck and head on out to the deployment site.
Okay, we brought our tools and our hardware back out to the deployment site. But before we continue with step 3, assembling it all together, we're going to talk for a second about pointing the corner reflector with respect to the radar flight track. So let's assume, for example, that our platform is going to be flying from north to south on 190 degrees heading. And then it's a left-looking radar, and it's going to be flying east from here, as simulated by John. Now your actual platform will be much higher and further away, but the point of this is that you want to set up your mounting stands so that when you place the corner reflector on them, it will be looking out towards the radar. Now having said that, let's continue to assemble the corner reflector and set it on those stands. To assemble the corner reflectors, lift the panels up into position like this and bolt the top and the bottom corners together first to hold it all together. Next, bolt the panels together along the edges. We generally skip every other hole. You can fasten them either using hand tools, a hex driver, and a wrench, or you can facilitate the process using a cordless drill. Also, check the panels for mounting bolt holes like this one. This is the panel that we're going to set on the mounting stand so that we don't have to recut these holes. Now we set the corner reflector on the mounting stand. Alright, at this point we're ready to do the finesse part of step 3, which is fastening the entire assembly to the ground such that it's aligned properly. Now on a flat field like this it's fairly easy to do, but often you'll have to deploy in more broken terrain, so you'll require a fair amount of adjustment and finagling to get everything set up right. First, you want to attach the corner reflector to the front mounting stands using bolts shot through the mounting bolt holes and shimmed up between the stand and the corner reflector using the washers before to protect the metal surface from buckling. Now, in doing the alignment procedure, we're interested in three things. First, we're interested in the orientation of the corner reflector. We want the front bottom edge to be parallel to the radar platform flight track, and we ensure this by using a compass like this with a flat edge on one side. The flat edge is placed against the bottom front edge, and the entire assembly is rotated left and right until the compass heading matches the aircraft or the radar platform flight track heading. Secondly, you want to ensure that the front bottom edge is level to the ground. We adjust this by lifting one or the other of the front mounting stands and shimming underneath using scrap wood, dirt, or anything that will make a suitable, solid mounting platform when the stakes are pounded through. Thirdly, we're interested in the inclination of the corner reflector, and we measure that using an inclinometer. Now, these mounting stands are cut so that on flat level ground, the corner reflector will be inclined properly. However, if you have an improper inclination, you can adjust it by shimming up underneath the back stand. Okay, now once these three characteristics are satisfied and you have everything set up in place, aligned properly, fasten the entire assembly to the ground by pounding the ground stakes through the mounting stands like this. Okay, we're almost there. Now, under long deployments or under windy conditions, we further anchor the corner reflector down by means of a guy wire assembly, which, to review, consists of an S-hook through a hole up at the top, attached to a turnbuckle, attached to a guy wire assembly, which you may want to mark with a flag because it's easy to walk into and they hurt a lot. This further goes down to an S-hook attached to a ground stake. Now, when the ground stake is pounded into the ground and the turnbuckle is tightened, it forms an extremely strong, tense support for the back of the corner reflector. This, together with two front guy wires like this here, will serve to anchor the entire structure down, and it will be extremely solid. Okay, finally we've made it to step 4, which is simply recording the position and location of the corner reflector. Now, in the process of setting it up, you may have changed the alignment, so you want to remeasure it. In this case, we have the front right corner is up 1/2 degree. The inclination is 14 degrees. And the front edge heading is 190.5 degrees. Now, to get the location, we use our Magellan GPS receiver. In any case, you want to mark down the location on a map referring to local topographical features. And that's it for step 4. Now on to step 5, which is simply clearing the area, taking some pictures, and monitoring it over the course of the experiment. All right, now it's on to step 5. While John hangs up a sign that says basically do not disturb and has a phone number for contacting us, and take some pictures aside, I'm going to start clearing the equipment away.
Hey, get that Cobra out of there.
Okay, we're done. That's it. Well, just about it. There is one more thing we wanted to say before we quit, and that has to do with the radar flight track. Radar flight tracks are generally specified with respect to true north. Now, behind me we have a schematic map of sorts, and here with the schematic radar and the flight track marked on top of the map. That's specified with respect to true north. However, when you're out in the field, your compasses obviously will indicate magnetic north. And the two are not necessarily the same. In fact, they're often not the same. So you want to make sure that you go out and look up the declination for the area that you're deploying in, and make sure that you adjust for that declination angle. And one more thing also, you want to, when you're doing the deployment, deploy the corner reflectors so that they're not close to one another. They shouldn't be closer than 200 meters at the very closest, so that the returns from two different trihedrals will not interfere with one another. Now, if you were to continue with the schematic here, let's say that our radar is left-looking, which I'll indicate with little left-looking arrows. You can delineate the imaging swath on the map by using, for example, two lines here. And the area in between will be the imaging swath where you deploy your corner reflectors. The goal is to deploy the corner reflectors evenly spaced across the swath, like this. Once those guys are set out there like that, make sure you clear the area away. Get the trucks, the vehicles, everything away from them so there won't be any interfering radar returns. One more thing also. The conditions that we showed you in this video were pretty darn near ideal. We had all the tools we need, all the hardware and the turnbuckles we needed. However, your conditions may well be far from ideal. You may be out in more broken terrain and so forth. So we want to encourage you to improvise. Do what you need to do in order to get the job done, in order to get the corner reflectors aligned and located properly. In particular, if you cannot manage to get them set up across the swath in a nice line like this, then it's okay to displace them in the along track or azimuth direction, like this. As long as the cross track or range spacing remains fairly even. Like so. One more thing, pointing tolerances. When you're aligning the corner reflectors, you want to have them pointed in level and so forth as accurately as possible. Now the front edge level and the inclination, those should both be accurate to within about 2 or 3 degrees. And the pointing of the corner reflector should be accurate to within 2 degrees or less. Now you can measure those numbers generally much better than 2 degrees. You should be able to measure it down to half a degree or a degree at the worst. But those are the pointing tolerances, 2 to 3 degrees and 2 degrees in case of pointing. One more thing, if you're deploying in a field where there's livestock, be it cows or horses or goats or chicken or pigs or reindeer, alligators, whatever, watch out, because in our experience, livestock like to come and investigate corner reflectors. We've had cows that have trampled, punted, uprooted, overturned, and fallen asleep in our corner reflectors. So you want to monitor the corner reflectors through the experiment and make sure that that kind of thing doesn't happen. In particular, you want to go back and measure the alignment as close to the overflights as you can, or at the very least when you're cleaning up, so that you know if they've been moved over the course of the experiment by whatever natural causes. Let's see, one more thing. We want to stress again that when you deploy, mark the locations of the corner reflectors where you actually deploy them as accurately as you can on a detailed map, like this here. That's so that when the data is processed, the images can be geometrically calibrated. And that's about it. If you have any questions or you need support, help, contact JPL. The contact person is Dr. Tony Freeman. And so really that is it. I think that's just about everything. So from all of us here at JPL, good luck, be careful, and have fun. Thank you.